Hi viewers, this is Sri Ramlu. So today's topic is a seven crystal system with Bravais lattice. So already I have uploaded the video seven crystal system only, not without Bravais lattice. Now I am going to do one more video that is with Bravais lattice. So here heading is seven crystal system with Bravais lattice. On the basis of the length and the directions of axis of the symmetry, all the crystals may be classified into seven systems. These seven systems again classified into 14 ways by Bravais by arrangement of lattice points. Here, on the base of the length and the direction. So generally, crystals are divided into seven. But Bravais scientist, he arranged lattice points in the middle, and the face, and at the bottom. So by doing this process, he converted seven crystal system into 14 crystal system. So those 14 crystal system I am going to explain in this video in details. So that is why you must watch this video till the end. Why? Because there is a one table with the complete descriptions. If you learn the table, then that is enough, but that table cannot contain any diagrams. Here only diagrams are given here, and there simply a table is there. And now see, first one, cubic crystal. In this crystal, all the three lengths of the unit cells are equal and are at right angles to each other. Right here, three lengths are same. Okay, three lengths are same. So generally, A is the length along x-axis, B is the length along y-axis, C is the length along z-axis. Like this, different lengths in different directions. So in the cubic crystals, three lengths are same. So that means equal. A is equals to B is equals to C. And angle C, the angle between axis is always perpendicular to each other, and then they are equal. Alpha is equals to beta is equals to gamma is equals to 90. Means alpha 90, beta 90, and gamma 90. That is the meaning of this. And see the diagram comes here. Here, let it is a x-axis, and this is y-axis. It is z-axis. Okay. So alpha angle is taken exactly opposite to the x-axis. Beta angle is taken opposite to the y-axis, and a gamma angle is taken opposite to the z-axis. Like this you have to take. And next, what he did, Bravais classified cubic crystal into three different types depending upon arrangement of the lattice points. Here, Bravais scientist, he classified cubic crystal, only cubic crystal, into three types. So what are those three types? See here, they are simple cubic crystal. It is denoted by P. Why? Because simple cubic crystal is also called as primitive. So that is why first alphabet P is taken primitive. P stands for primitive, or it is a simple. It's meaning either primitive or simple. These things are given at the end of this video. So that is why you must watch till the end of this video. Okay. So simple cubic crystal, body centered cubic crystal, face centered cubic crystal. So like this, how many? Three different types are there, and those three are given here. Okay, and see here, here. So primitive or simple cubic crystal is it is a cube containing 8 lattice points at the 8 corners only, so that is why it is simple. And it is a cubic I stands for what? Body centered. So 8 lattice points present at the 8 corners. Okay, along with 8 lattice point, one more lattice point will present exactly in the middle of this cube. So middle of this cube, so that is the center of this cube, that is why it is called body centered. It is denoted by I, body centered cubic crystal. It is a cubic crystal. And next, face centered. So face centered means generally how many faces contain a cube? Totally 6 faces it contains. Okay, at the center of each face one lattice point he kept at the center of each face. So totally how many faces? 6 faces, means 6 lattice point he kept at the each faces, in middle of the faces. That is why it is named as a face centered cubic crystal, right? Face centered cubic crystal. And see here, and not only at the face, commonly here 8 lattice point must, we must keep 8 lattice point at the 8 corners, then only we have to do extra things, extra operation means we have to keep in the middle, or if we can arrange the lattice point at the middle of the each faces like this. So for face centered lattice point, one lattice point present at the center of this right side face, and a top face, bottom face, back face, front face, left face, like this. Totally 6 faces contains 6 lattice point at their center. That is why it is called face centered cubic crystal. And good example for the simple cubic good example for the cubic crystal is NaCl, sodium chloride. So sodium chloride structure is always, that is a face centered. Next, second crystal is tetragonal crystal. In this crystal, two lengths of unit cells are equal, only two lengths are equal, while third one is longer. The three axes are perpendicular to each other. Three axes are perpendicular to each other. Okay, and see here, only two lengths are same, a is equals to b, and third one is different. Okay, it is not always longer, it is sometimes shorter also, but it must be different, third one must be different. And alpha, beta, gamma all are equal, and they are 90 degrees, they are perpendicular to each other. And a diagram for this is, see, this is the diagram. Okay, a is equals to b is not equals to c, alpha is equals to beta is equals to gamma is equals to 90 degrees. It is a tetragonal crystal. And what he did, Bravais, what he did, so for this, how many he changed. So Bravais classified tetragonal crystal into two different types depending upon arrangement of lattice points. So depending upon arrangement of lattice point, how many he changed, he converted two different things. So they are what? They are simple tetragonal crystal, body centered tetragonal crystal. Okay, simple tetragonal crystal, body centered tetragonal crystal. So it is a simple one, and it is body centered, see, at the center of the body. And good example for is NiSO4, nickel sulfate. Next, third one, orthorhombic crystal. In this crystal, the lengths of unit cell are different. See, all the lengths are different, but three axes are perpendicular to each other. Here, three lengths are different, but axes are perpendicular to each other and they are equal. Okay, so for this diagram, so this is the diagram. Okay, according to Bravais classified orthorhombic crystal into four different types. See, he turned, he changed it as four different types depending upon the arrangement of lattice point. So I have written everywhere the same point, but just I am changing what this point and the names are changing. So why? Because it is very useful for remembering. So that is why I have changed it like this. So please keep it in mind while preparing. Okay, they are: one is simple, body centered, face centered, base centered orthorhombic crystals. So that means simple orthorhombic crystal, body centered orthorhombic crystal, face centered orthorhombic crystal, base centered orthorhombic crystals. Like this, how many? Four different types are there, and with a diagram also given. So this is a primitive or simple. A simple can contain the eight lattice point at the eight corners. But see, orthorhombic, C stands for, it is base centered. See, it is at the center of the base. Or if you turn this, then this come downside, then that is base centered. Okay. Or if you turn it like this, if you turn it like this if you turn it like this, then if it come base, then at this point, at this place, we have to keep one lattice point, then that is it is then it become base. Okay, now base means which is touching to the ground, that is the base. So it is touching to the ground, so that is why it is base, and at the center, so that is it is a base center. Okay, and the next, what, third one is orthorhombic. I means body centered. Okay, C means base centered, I means body centered, F means face centered, at each faces containing one lattice point at their centers. So that is why face centered. So here, 1 2 3, okay, 4, and 5, and front side 6, like this, 6. Okay friends, so these are the orthorhombic crystals. An example is a potassium nitrate. Next, trigonal. In this crystal, all the three lengths of the unit cells are equal in lengths. Moreover, they are equally inclined to each other at an angle at an angle other than 90, at an angle other than 90. And see here, all the sides are same, he's saying, and all the angles are same but not 90 degrees. Okay, all the angles are same but not 90 degrees. And an example for this is a quartz and calcite crystals. Quartz and calcite crystal, see here. So this is the diagram according to Bravais classified trigonal crystal into one type only, depending upon the arrangement of lattice point. That is simple trigonal crystal. Only one crystal will be there. That is simple trigonal crystal. That simple trigonal crystal is, see here. This is simple trigonal. Simple means at 8 corners, 8 lattice points present. That is a simple one. Next, hexagonal. So in this crystal, the two sides are equal, but third one is different. Two sides are equal, A and B are equal, third one is different. And two axes of unit cells are equal. Only two axes of unit cells are equal and perpendicular to each other. But third angle is, so not and here, third angle is 120 degree. Third angle is 120 degree. So like this, see, alpha is equals to beta is equals to 90, but gamma is 120 degree. Only gamma 120 present in hexagonal diagram. So it is a hexagonal diagram. according to Bravais. Bravais classified hexagonal crystal into one type only, depending upon the arrangement of lattice point. That is simple hexagonal crystal. Okay, see simple hexagonal crystal how it is. It is a simple hexagonal crystal. At a see how many corners? One, two, three, four, five, six. Hex means what? Meaning of hex is six only. So totally the bottom 6 and the top 6 totally 12 lattice points are there. Next, monoclinic crystal. It is a sixth one, monoclinic crystal. In this crystal, lengths of unit cells are different and the different. The two axes are at right angles, and third one is obliquely inclined. Obliquely means with a certain bend, not 90 degrees. Other than 90 degrees is oblique. That is A is not equals to B is not equals to C. But alpha is equals to beta is equals to gamma. Alpha is equals to beta is equals to 90, but not gamma. So gamma is different angle. And a good example for is Na2SO4 for this. See the diagram. So this is the diagram. But according to Bravais, Bravais classified the monoclinic crystal into two types depending upon the arrangement of lattice points. Okay. They are simple monoclinic crystal and a base centered monoclinic crystal. Okay, so base centered word has repeated. This is second time only. So one first time in orthorhombic and second time is in monoclinic only. Base centered can present in these two things only. And see the diagram. So it is a primitive or a simple, and this is what base centered we should not write b, we have to write it as c. Okay, so it is if it is a base this side, if it is base this side. And next last one is a triclinic crystal. Triclinic, in this crystal, lengths of unit cells are different and oblique to each other. A is not equals to B is not equals to C, and alpha is not equals to beta is not equals to gamma, and not equals to 90. See, all the angles are different and they are not 90 degrees. Right? All the angles are different. Three angles are different, but they are not 90. According to Bravais. Bravais classified triclinic crystal into one type depending upon the arrangement of lattice point, that is simple triclinic crystal. So this is a simple triclinic crystal. Okay, out 8 corners, 8 lattice points are there. And this is the important things. Okay, I have written, see here, P stands for primitive or simple. I stands for body centered. F stands for face centered. C stands for base centered. Okay. With example, this diagram is given. And see here, cubic crystal. A cubic crystal, how many Bravais lattice it contains? 3. They are PIF. P stands for primitive means simple. I body centered. F face centered. Tetragonal 2 only. And what are the twos also given? Orthorhombic 4. Here C has come and here also C has come. Base center. Next, trigonal or rhombohedral. Another name of trigonal is rhombohedral. Only one. Hexagonal 1. Monoclinic crystal 2. Triclinic crystal 1. And what is logic here? You have to keep in mind as C T O T H M T. C stands for cubic, T stands for tetragonal, again O stands for orthorhombic, this T stands for trigonal, H hexagonal, M monoclinic, T triclinic, like this. Why I have taken this in this manner? Because see here, In cubic all sides are equal, and in trigonal so only two sides means cutting started from this, and in orthorhombic so two cuttings are there. Okay, and next what fourth one is again repetitions. Okay, and this is also repetition, and next this is also repeated twice. That is why I have taken this order: ctot hmt. Keep in mind as ctot hmt. Okay, and next angles also see, all the angles are same, 990 angles are same and 90 angles are same and 90 angles are same, not 90 angles. Two angles are same and 90, but gamma is 120. Two angles are 90, but third angle is not 90. So all angles are different and not 90. Okay, so equal, here equal, one is unequal, one equal, all equal. So so these equals is repeating one. So one two three. So this is also after third only this will starts repeating. So that is why till third all angles are same. Okay, so that means it is same. But from this, when repetition start, when it is repetition started, from there here cuttings also started. Two three angles are same but not 90, and here one cutting. So here all are equal. Okay, here one cutting, two angles are same, third one is what, 120. Here all are different, here also all different. Here what, all are different, and two are same, 90, but third one is not 90, but here all are different. So like this different cases are present, and keep it in mind as CTOTHMT. And how can we remember this T? Three T's are there. First T is a tetra, second T is a tri, third T is also tri. Okay, so try started from this only, and a try ends with this. And keep it in mind as a triclinic. Clinic mean hospital. So if you get any accident, then what will you get after trying many time trying? You may reach to the clinic means hospital. Like this, keep it in mind. So it is the first try, not, it is not clinic. So last try is a clinic. Okay, so finally we go to the hospital when we got accident. So keep it in mind this, and examples problem examples also given. Okay, okay friends, thank you. Don't forget watching this video till the end.